Hello, student. Welcome back. Today we're going to be talking about the limit laws. So a lot of people are intimidated by the limit laws because if you look here, what do we have? 9 of them. And some of your teachers might be encouraging you to memorize these. I don't think that's a good use of our time. I think that the limit laws look really intimidating, but they're actually pretty straightforward when we start to use them. Okay, so let's take a look. We've got the sum law, which says that if we are taking the limit as x goes to some value of f of x plus g of x, it's just the limit of f of x plus the limit of g of x. The difference, the same as the sum law, we can just separate this into 2 limits, the limit of f of x minus the limit of g of x. The constant multiple law says that if we're multiplying c by a function, we can take that constant out, that c out of our limit. The product law, if we're taking the limit of a product of 2 functions, f of x and g of x, we can just write that as the limit of f of x times the limit of g of x. And this is really all these limit laws are. F of x over g of x is the limit of f of x over the limit of g of x. The only issue here is if the denominator is 0, we'll run into a problem. The limit of f of x to some power, we can take that power to the outside. If we're doing the root, some root, where n is positive, where we're not dividing by this root, then we can just take that to the outside as well. And I think really the 2 most important to start with, the limit of a constant. If x is going to some value a, and we're taking the limit of a constant c, or let's say, the limit as x goes to 2 of 4, this is just 4. Nothing's happening. As x goes to 2, the function is always 4, so our limit is just 4. And the second one is the direct substitution law. So as the limit of x goes to c of f of x, if we have no issues at c, we can just plug c into f of x. So the constant rule and the rule of direct substitution are the most important that we're going to use. Okay, so let's use these limit laws with the graphs of f of x and g of x here. I'm going to zoom in a little bit so you can see this. Okay, so the limit as x goes to 2 of f of x plus g of x. So we separate these. We take the limit as x goes to 2 of f of x, which as x goes to 2, we're going to -1 on the left and -1 on the right. So this limit would be -1. And g, as x goes to 2, looks like, oh, I thought we had a problem, but as we go to 2, we're actually just going to 0. So -1 plus 0 is -1. All right, the limit as x goes to 1 from the left of g of x, as x goes to 1 from the left side, we're going towards -2. Now the limit as x goes to -1 of f of x over g of x, so f of x, as we go towards -1, is going up here towards 2. So this would be 2 over g of x would be 0. Okay, so our denominator is 0. So this would be undefined. Or the limit does not exist, rather, because we're talking about limits. So the fraction is undefined, but the limit does not exist. As we go to 2 from the right of f of x over g of x, 2 from the right is -1 of f of x, and of g of x, it is also -1. So this is 1. All right, keep on going. The limit as x goes to 1 of the square root of 3 plus f of x. So we're just inserting this limit on the inside. So the limit as x goes to 1 of f of x is 0. So this is the square root of 3 plus 0, or just root 3. The limit as x goes to 2 of f of g of x. So we can take f to the outside and just take the limit as x goes to 2 of g of x. So that is 0. And then we're going to take the limit as x goes to 0 of f of x, which is 1. Now we've got two functions multiplied by one another. We have x cubed on the left, f of x on the right. So the limit as x goes to 2 of x cubed is 8. And the limit as x goes to 2 of f of x is negative 1. So 8 times negative 1 is negative 8. Okay. Multiplying functions again. So 2 times the limit as x goes to negative 1 of f is 2. Negative 1 of g is 0. So this will just be 0. Okay. The limit as x goes to 1 of g. So the left-sided limit is negative 2, and the right-sided limit is negative 1. So our limit does not exist. And finally, the limit as x goes to 2 of f of x. We've actually used this a couple times before, but left side is good. It's negative 1. The right side is negative 1. So this limit is negative 1. All right, I hope this helped you understand the limit properties a little bit better and the fact that you don't really need to memorize them. Have a great rest of your day.